Okay, a small internet service provider has 10 identical routers. We have already read this and we know 10 is 10. They find that in the long run there is at least one faulty router on 65% of all days. So the probability that x is greater than or equal to 1 equals 0.65. This is new because we've actually been given the answer. We've got to find the other way around. We've got to find pi. Calculate the probability that an any given router is faulty on one day, assuming that the number of faulty routers has a binomial distribution. So we're given this. So we know that 1 minus the probability of x being less than or equal to 0 equals 0.65. That's okay? Except the probability of x being less than or equal to 0 is actually the same as the probability of x equaling 0. So I know the probability of x equaling 0 equals 1 minus 0.65. There was some fancy algebra there. Yeah? And we can remember that n is 10. So we've got the probability of x equaling 0 equaling 0.35. This is where you need to go back in the book, 1 page, 2 page, 3 pages to page 144, and you have got the probability of x equaling x equals the ncx pi to the x and 1 minus pi to the power of n minus x. Okay, so now what do we do with that? Okay, I'm going to just move that to there. This is the special case. So we've got the probability that x equals 0 equals 0.35, which also equals, so x is 0, so 0's there, 0's there, 0's there, and n was 10, so 10 is there, and 10 is there. Now anything C0 is actually 1. Anything to the power of 0 is 1. So we've got 1 times 1 times 1 minus pi to the power of 10. So what we're solving is 0.35 equals 1 minus pi to the power of 10. So we know 0.35 to the power of a tenth equals 1 minus pi. So we know that pi equals 1 minus 0.35 to the power of a tenth. So we can go menu, run, there we go, exit. Oh, that's what I was showing you before, that the 10C0 is in fact 1. Okay, so I'll just exit out of there, get back to there, clear, and I'm going 1 minus 0.35 to the power of a tenth, otherwise known as 0.1, is, so pi equals 0.0997. And let's check. Yes, correct. Alrighty, so that's a cool trick. It's at least a merit, depending on the context of the question. Okay, so it's a good one to know, good one to have practiced.